Now we will see how to find out the maximal element, minimal element from the given poset. So we will see first what is meant by maximal element and what is meant by minimal element in given poset. An element A in a poset s comma less than equal to is called maximal element if no element B in S exists such that A is lesser than is equal to B. So in given poset, element A is called as maximal element if there is no any element B in S such that A is lesser than equal to B. If there is one unique maximal element A, it is called as maximal element or the greatest element. So if it is a unique element among all the set S, then it is called as a greatest element. Sometimes two or more maximal elements also present separately. That's why if unique element exists, then it is called as a greatest element. External elements or minimal element from the given poset. An element A in a poset S comma lesser than equal to is called minimal if no element B in S exists such that B is lesser than is equal to A. Means A element from poset S is called as a minimal element if there is no any element B such that B is lesser than is equal to A. If there is one unique minimal element A, it is called the minimum element or the least element. So these are the example of poset by hash diagram, represented by hash diagram. So in this we can find out maximal element and minimal element. So in the first diagram, if you see, maximal elements are nothing but G, H, I, and minimal elements are nothing but A, B, C. In case of second diagram, maximal element is H and minimal elements are 2, that is A and B. Upper and least upper bound. Let S is S comma lesser than equal to be a poset and let A is a subset of S. If U is an element of S such that A is lesser than is equal to U, for all A belongs to A, then U is an upper bound of A. Means in given poset, if you take any subset, that is A is a subset of S, and if you try to find out upper bound, so upper bound particular U element U is an element of S such that A is lesser than is equal to U for all A belongs to A, means U is greatest element among the all elements present in that particular subset A. Then that U is called as upper bound of A. An element X that is an upper bound on a subset A and is less than all other upper bounds on A is called the least upper bound on A. We abbreviate it as LUB. Now we see in upper bound, so least upper bound is the smallest upper bound among all the upper bound which is exist in the subset A. Is called as least upper bound. Lower bound and greatest lower bound. Now let S comma lesser than is equal to be a poset and let A is a subset of S. If L is an element of S such that L is lesser than is equal to A, for all A belongs to A, then L is an lower bound of A. So it is opposite of upper bound. Here A is a subset of given poset S, means set S. L is called as a lower bound if L is lesser than equal to all the elements which are present in set A. Then it is called as a, if it is lowest among all the elements from the set A, then it is called as lower bound of A. And element X, that is a lower bound on a subset A and is greater than all other lower bound on A, is called the greatest lower bound on A. We abbreviate it as a GLB. Means greatest lower bound, we know that lower bound. Now greatest lower bound is nothing but if there are multiple lower bound in subset A, then greatest lower bound among these all lower bound is called as greatest lower bound, means whose value is greatest among all lower bound which is existing A. It is called as greatest lower bound of A. Example. So in this example, give lower bound, upper bounds, GLB means greatest lower bound, least upper bound of the sets. So subset given of given poset is, first one is DEF. We have to find out DEF. These are the elements of subset. Then A comma C and B comma D. B and D. So we have to find out the lower bound, upper bound, greatest lower bound, least upper bound of these three sets. We will see one by one. DEF. If you see DEF, in case of DEF, lower bound is 5. Therefore, there is no greatest lower bound. You can see DEF, lower bound. There is no any element which is attached to all these three elements. When you are finding the lower bound, you have to consider all the elements from that subset. Here this B is connected with D and F, but it is not connected with E. That's why B is not a lower bound. So there is no any lower bound. If it is connected, then we can declare it as a lower bound of this subset. But here it is only connected with D and F, so it is not a lower bound. So it is a 5, lower bound is 5, and as there is no lower bound, so there is no question of greatest among these lower bound, multiple lower bound. So there's no lower bound, no greatest lower bound. Now upper bounds, in the same way, upper bounds for this, it is G is connected with D and E, so we can declare it as a upper bound of G, D and E, but it is not collectively the upper bound of DEF. In the same way, I is not connected with DEF, so it is not upper bound of all these three vertices. So there is no upper bound. So as upper bound is 5, thus there is no lower least upper bound. Second subset is AC. In case of AC, if you see A and C, lower bound is nothing but lower bound here is 5, so there is no question of greatest lower bound. Lower bound is 5, so thus no greatest lower bound. Again, if you see for AC, upper bound is H and it is least upper bound also. Upper bound is H and least upper bound is itself, because there is no multiple upper bounds. Now we'll see the last set B comma D. So in case of B comma D, this is B and this is D. In case of B and D, least upper bound is nothing but B, because if you consider this both element, B is the lowest element, so this is the lower bound, and greatest lower bound is nothing but, you can see this here, lower bound is B and greatest lower bound is also B. In that case, upper bound for this B and D will be D and G. You can see here, upper bound is D and G, and least upper bound among this is nothing but D, because D and G, these are the upper bound, and least upper bound is D because D is lesser than G, lesser than equal to G. So this is the example. Now you try to solve this. Find all least upper bounds and all greatest lower bounds of A on this hash diagram. Use the subset of this coset. First subset is B1 is equal to A comma B, and B2 is equal to C, D and E. You try to find out this. In the same way, find the least upper bound and greatest lower bound of B is equal to 6, 7, 10 for the following hash diagram. In the same way, what will be seen in the first example, try to find out least upper bound and greatest lower bound of this subset. In the same way, these are the some example. Now lattice. Based on the whatever definition we seen about upper bound, lower bound, then greatest lower bound, least upper bound, lattices is nothing but it is a partial order in which every pair of elements has both a least upper bound and a greatest lower bound. Then it is called as a lattice. Means in given coset, if every pair in which every pair of element has both least upper bound and a greatest lower bound, then it is called as a lattice. So you can take the example. In this example, we will try to find out. You can take any pair of the vertices and try to find out its upper bound, then lower bound, then least upper bound and greatest lower bound, least upper bound and greatest lower bound. If it is exist for every pair in the given diagram, then it is called as a lattices.